In this DataGraph demo, we're going to talk more about volcano plots. The last video actually created this volcano plot where this is a scatter graph and every point represents a gene, and the distance that point is from the origin gives us some information about how significant this result is. And you can see from this plot we have points that are indicated as red being upregulated and blue being downregulated. We also in the last video made this very dynamic so that if I changed any of my significance regions, the graph updates as well. In this video, what we're going to do is we're going to think more about how can we rank these genes according to their level of significance. One way is to calculate the distance that the point is from the origin. This would be called the Euclidean distance, and this is just taking a straight line from the origin to the point. So this point, for example, would be considered pretty significant. Now, there's another way that the distance is calculated for these types of plots, and it's a distance that we refer to as the Manhattan distance. And why do we call it that? Well, it's because if you're in Manhattan, then we can't necessarily always go in a straight line from point A to point B because there are these things called buildings in the way. So we have to follow according to a block pattern, and that can make our path actually longer than it otherwise would be. So for the Manhattan distance, our path would be the change in the y direction, and we would add to that the change that's in the x direction, and this would be our total distance. This is what we're going to do today. We're going to calculate both the Euclidean distance and the Manhattan distance in DataGraph, and I'm also going to then use that data to create the graphic you see here. This is a bar graph that gives me the names of the genes and has them ranked in both regions. And I think that looking at both of these graphics gives us a really full picture of what the results are of this experimental data. And again, in the very DataGraphy way, I can change my significance regions in either direction. And when I do, not only does my plot update, but my bar graph does as well. This is what we're going to work on today. So get DataGraph ready and let's get started. We're going to start by using the DataGraph example file that we uploaded from last time called Volcano plot. This is the basic volcano plot that we used last time, that we created last time. Go ahead and open this file. And when you do, it might take a moment for the data to load in because this is data that is from an online repository. The data group that links to that data is over here. I'm not going to go into all the details of how this was created because I did that in the last video. But briefly, just so you see what's in here, I have the data itself and also these two mask columns where if there's a 1 here, it indicates that the gene referenced in that row is either up or down regulated. This is created using these region commands over here in the graph. And this is connected to these sliders that I mentioned before that make this all very dynamic. The first thing that I'm going to do is I'm going to add redirect columns. And there's two reasons I'm going to do this. One, it simplifies our column names, so they'll be easier to use in my calculations. And also it will make it easier for me to replace the data that's going through the calculations and also into the graphs. So if you've never used a redirect column before, you can add them over here, go over to your column list. Notice I also did change the name of this file. This is going to be Volcano plot with ranking. So up here at the top, there's another drop-down menu that you can click that and go to the redirect option. If you select this, this adds a new object to the list where we can again create this sort of an alias for our data. And we're going to do this for all three columns, the gene names, the difference, and the p-value. So the first one, the gene names, we can select that. It will give an error because by default this is number. We need to just specify this, make it clear that this is a text. And I'm going to just call this gene. Now that I have this one created, I'll hold the Option key, click and drag to clone this. There we go. And now use the difference column, which is a number. So change that one back to a number. And I'm going to simply call this X, since this is my X data. Do again, Option, click, drag. Here's my Y and my p-values. And now I have the inputs redefined with simpler names. Let's go ahead and hide the raw input data. And I'm going to place this in its own group. So I can click and drag to select these three objects. Click the group icon up in the at the top of the column list, and we'll call this inputs. And I also kind of like changing the colors here. So if you click the gear menu, we can change this color. We'll go ahead and make this one green. Now that I have my redirect columns set up, I want those to be the inputs to my graph. Then if I change my data, everything will update based on these inputs. Okay, so what I'm going to do here is for each one of these plot commands, I'm going to change them to use the input columns. The X and the Y, therefore, can be updated to use X and Y. One quick way is to click the header of X and to drag this and drop it right onto that menu. So now X is coming from my inputs table. Same thing with Y. We're going to change this instead of going from the raw data to these redirect columns. Now, once you've done this in one place, a very handy shortcut to then populating within these other commands is to hold the command key, and then you can click from one menu and drag and populate the next menu. So it makes it really fast to do this. So again, hold the command key down, click from one menu, and drag it and drop it onto another menu. Saves me a lot of time. I use that shortcut all the time. There's one more thing that we need to do here is that the gene names that are used in the hover, we set that up last time. This is in the hover label. We also want that to be updated. So we can drag and drop that from here. And we do need to do this for each of these commands because they're overlaying one on top of another. So we want to make sure that the gene names are all coming again from that column. Once I have this all set up, you can confirm that this was done correctly by clicking the gear menu on any of these objects, and you can check what the supplier is. And sure enough, if you see my nice little green arrow there showing me where this is coming from, it's all coming from the input columns. Now let's calculate our distances, the Manhattan distance and the Euclidean distance. We're going to do this using an expression column. So you can go over to your column list, and up at the top there's the shortcut for adding an expression. Go ahead and add two expressions here. And I'm actually going to put these objects within the same group as the inputs that I created. The first one we will call Manhattan, and the second one we will call Euclidean. And the calculation of this, the Manhattan, for example, is going to use these X and Y values. So again, this makes my typing out of this equation much simpler because I made my column names a lot simpler. Here, to get the Manhattan distance, we can take the absolute value of the X value because that can be positive or negative. We just want the distance plus the Y value, which will always be positive, so I don't need to take the absolute value, and enter that. Now we have the Manhattan distance. For the Euclidean distance, we're going to use again, the Pythagorean theorem. So this is x squared plus y squared, and we will take the square root of that. So there is a function sqrt for the square root that we can go ahead and enter, and hit enter, and now we have the Manhattan and the Euclidean distance. Now I do want to add one more redirect column that will let me select the one that I'm going to use in the next part where we create the bar graphs. So let's go ahead and add one more redirect. Actually, I think I will again clone my last redirect that I made here. So selecting my object, holding the option key, option drag. We'll call this one, let's see, select distance, and we can then from this use again either of the Manhattan or the Euclidean distance here. And actually I'm going to go ahead and I just remembered how I wanted to put the full name here, Manhattan distance and Euclidean distance, into this. And now I can select which one I want, and we'll use that in our bar graphs. Now we're going to make our sorted bar graph with just the genes that are significant. So to do this, first of all, we're going to use the pivot command. We're going to make a new graph, and I don't necessarily need to see the data panel here, so let's go ahead and hide that. And before you add the pivot command, we can pre-select the data. Click the header for the gene column to select that one. Hold the command key. Make sure you can see my keystrokes here. Hold the command key and then also select the distance column. With those two selected, add the pivot command. This is now showing me all my data in this very large bar graph for all these genes. This is definitely a lot more than I want to see. So I'm going to mask this based on the columns that I already have here that tell me whether or not a particular row is up or down regulated. So let's start with the upregulated genes, and I can again click this header and quickly drag it and drop it here on the mask. I'm going to set my mask so that when the column up is equal to 1, I'm only seeing those genes. So this is showing the ones specifically that are within these regions. And sure enough, right now I have it set up for 3 genes, and or there are 3 that are in that region, and I see those same 3 here. I also want to sort this. So change the sorting from automatic to decreasing. And I want to change this from the type being from being X standard to being Y standard. I want these to be going horizontal. I'm also going to add a bit more space here on space for my label on the Y-axis. You can do that within the axis settings. You'll see here, this is the option, space for Y. You can change this. In this case, we're going to do exactly, so that lets us make this much wider. And and the other thing that I want to do here is I actually want the largest ranking gene at the top of my bar graph. So let's change the Y type from linear to reversed. And this looks pretty good. Now let's add the bar graph for the downregulated genes. And we're going to do this by using a split graph. Go to the canvas settings and you'll see there is the split Y button here. Click that. That gives me 2 different axis regions that I can have graphs on. I'm going to clone the bar graph that I have here for the second one. So select it, hold the option key, click and drag. And let's go ahead and move this one up to the top. Now notice that the order hasn't been reversed here. This is actually a separate setting for every axis. So this is the object that got added when we split our Y's to 2 Y-axes. And you can change this one also now to be reversed. Perfect. Now what I want to do is I want to change the data that's in this one. And the way to do that for this bottom graph is we will expand this up and just change the mask. It's the same data that's going into this pivot command, but now we want this one to only show the genes where the down column is equal to 1. So now I have my 2 graphs. Another thing that I want to do here is I want to change the color of these. If you go into the pivot command and scroll down a bit, you'll find all the color tiles. The pivot command is really set up to do a side-by-side bar charts for multiple categories, but here we just have this one category essentially. So here we can just change this first color tile to whatever color we want to use. This is for the downregulated, so we'll change this to the blue color. And for the upregulated, I'm going to change this to red, and that will match the colors that are in my volcano plot. Now let's do some additional formatting of this bar graph. And I don't know about you, but when I look at this, it really bothers me that the bar widths are not consistent between my top graph and my bottom graph. The way to modify this is to actually change the amount of space allotted for the split graph that I added. And the split region is the one that's on the top. Again, this is the object that controls the split region. So I can open this up and find the option or the menu that says height. This has an entry box and a slider associated with it. And this is a relative setting. It changes the proportion of the graph that is allotted to the split graph. So when it's less than 1, it makes this top graph shorter than the graph that it's being compared to, the main graph. And what I want to do is I want this to be completely dynamic. And I can do this by using the total number of bars that I have in each graph. And that's something that I can calculate dynamically based on my columns here. So what I'm going to do is let's first just open back up my data panel, and I want to calculate variables for each of these that will sum up the total number of up and down regulated genes. So go to this column, you can control click on the column itself, and you'll see the number from column option, and I want to select the sum. This is going to create a variable, and here it is. I'm going to just call this up. Sure enough, it has a value of 3, which is what I would expect. Let's do the same thing for the down column. Let's right click on this, number from column, sum, and this one is down. So now over in my height, this box, which can be a number, can also be a variable, and it can also have mathematical expressions. So I'm going to actually type up divided by down. And now if you wanted to compare these bar widths, they are exactly what I want them to be. And even if I change my significance levels, the bar widths will stay the same on the up and down graphs here. Now let's add some labels into this bar graph. And one of the things that I want to do is I want this bar graph to tell me what column I'm using for ranking the data. Am I showing you the Manhattan distance or the Euclidean distance? And this is something that I can actually set up where it's going to pull that name of that column through the redirect column that I created. And I'm going to use a variable over here that's a text from column variable. Use this other menu above where the variable section is and find the text from column option. When you select that, it creates this object, and it has a menu at the bottom here that tells me or lets me specify what do you want to pull from a column. And what we're going to pull is the column name. And the column that we're going to pull this from is the one that we set up in the inputs that's called select distance. Now what's interesting here is the redirect columns are set up so that it doesn't show you the name of the redirect column. That's a pass-through column. It's showing you the name of the original column that the data is coming from. So this is exactly why we set up this type of column, the ability to do this. So let's call this my rank basis. And I can now use this variable as a token in my X title. So if I go over to my axis settings and click right next to the text entry box, the menu there, select rank basis, hit enter, and now you see that this is the Manhattan distance. And if I go to the variable or the column where I have this redirect set up and I change this to Euclidean distance, it's going to change the output and it's also going to change the label so it stays consistent between the two. We'll also add labels here to show us if this is the upregulated or downregulated. I can do that using a text command. So if you go over to the label menu, find the text command. Let's add one of these. And in this object, we can specify where we want the command. I want this to actually be in the lower right corner, so anchored to the lower right. And instead of aligning this to the left, let's align to the right. Now you should be able to see this text command here. And what text am I going to put here? Well, this one would be called down, and add a second line, and we will call this regulated. There we go. Now let's add a little bit of an offset here because I don't want it right next to the edge. That looks a little bit better. And the other thing that I want to do here is add one obviously for the graph above, the upregulated. So I can take this text command, hold the option key, click and drag again to clone this, but we're going to place this one in the upper graph and we'll change this from down to up. Thanks so much for watching, everyone. We successfully created our ranked bar graph. This, again, is very dynamic, so we can change our sliders and the bar graph will update accordingly, just like the Volcano plot does. This is a file, too, that you can bring your own data into, and because we created these redirect columns, you would put your data into its own group, go into the input column section, and in here, use the redirect columns to select the data that you want to use. And both the Volcano plot and the bar chart should update. I hope that works out well for you. Let us know if it does or it doesn't. I also am going to include in this file here, which is very close to the one I will upload as an example file, an illustration that I showed you earlier of the Euclidean distance and the Manhattan distance. So with that, I wish you well, and I look forward to hearing how this file works out for you in creating your own volcano plots.